All right, we may as well get started. It's 7:15. So I'd like to welcome everyone to the May 2022 meeting of the Mid-Atlantic Amateur Radio Club. I'm Jeremy Carlo, N2 ZLQ Club President. So as we normally do, we'll go around the table, let folks introduce themselves. Let's try to get a pile up here.
Rich, KB3VZL.
Alan, AB3FN.
Dick, K3ITH.
Dennis, K3DS.
Bob, N3, JIZ.
JW2AFE.
Ed, WQ3Z, am I making the machine?
Yes, you are. And if anyone else on YouTube would like to check in as well, you can just type your name out in the chat and I will acknowledge you a little bit later on once I get back to that. Okay, so let's head through committee reports for the evening. Let me bring up my notes here. So first, a report from the treasurer. Lou is not here, but there aren't any major changes since last month. I don't have the numbers here, but it was about the same as what was reported last time. So repeaters, Dennis, you want to talk about that?
Yeah, the flagship 14706 repeater had intermittent problems of unknown origin. They remain problems of unknown origin. To try to figure out if there was a way to mitigate it, I took the power amplifier off. So we're now running a whopping 3.5 watts coming out of the duplexer as opposed to 80 watts coming out of the duplexer. So actually, no, let me take that back. With the duplexer, we'd be running about 45 watts. Lose a little bit in the duplexer. I am going to try to do a few more things at the 06 site because I'd like to get the power back up again, although most people don't seem to mind it. It certainly is just a little bit weaker in certain locations. Let's see, other things coming along. We have a possibility, a very good possibility, because I saw some pictures tonight of using the new 444.050 repeater out of Derby, which will be possibly hooked up to Yaesu Fusion and therefore out to the internet through the courtesy of K3ZFT. I'm going to be doing the same thing with 445.675, hosting it out of Paoli. So what that means is that we'll have some capabilities of having some wider area coverage by using the internet like other people do on certain frequencies, and we'll see how it goes to stir up some activity. Derby remains work in progress. The 147.36 is on the air. Very, very short squelch tail. That's the way Bridgecom designed their repeater, but it does CWID. And the 220 repeater at Derby is not currently there. And there is, of course, some discussion about it, whether we're actually going to put a 220 repeater back on again. Repeater use in general is very, very low, in fact, extremely low. And as a result, if I'm trying to debug what's wrong with 06, it's kind of hard because I don't get any data points. Days go by and I get no activity at all. So kind of hard to figure out what's going on. So that's the report. Jeremy, back to you.
All right, thanks. Yeah, so use the repeaters. Let me see, I can share the pictures that Steve sent. Let me pull that up here. So here's what Steve sent. So this is the radio. It's a Yaesu FTM 100, which is the Yaesu dual band Fusion Mobile. And then there's the little wires Xbox, which he has up on top of it. That's a power supply. This is the antenna. So it's a dual band Yagi antenna, but I think he'll just be using the 440 part of it. And then next to it, I believe that's the computer that runs the software. Is that right, Dennis?
You're muted, Dennis.
I don't know what that is. He didn't identify it.
Okay. No, I think that's the antenna.
I take it back. I think that's a router. I think that's a
Oh, the
router.
router.
Yeah.
Okay.
I
Yeah,
saw
the antenna. That is QTH. So I think the plan is to mount the Yagi in a vertical configuration, probably off the base here, and it points towards the 444.05 repeater. That's the antenna and some of the coax. So it's a pretty nifty setup. So he'll be using the internet at his house, and then anyone who uses the 444.05 repeater with a fusion capable machine will be able to access Wires X capability, which means getting into all of those various they call them talk groups or reflectors. I don't do fusion. In DMR, we call them talk groups. But that'll enable that. And then Dennis is working on a similar setup that would enable connectivity from 445.675 in Paoli. All right, so that's repeaters. Let's go to public service. Bob.
Okay. We had a public service event this past Saturday, May 21st. That was the French Creek Triathlon. It was held in the French Creek State Park, and it was a very, very warm day, but it fortunately, fortunately or unfortunately, we got there bright and early at 6:30 in the morning. So the heat wasn't too bad at that time. And we helped out with the bike race, and things went pretty well for us. There was, I guess, two ambulance calls, I guess. I don't know what the totally what the reason was. I think one was a broken wrist, and don't know what the other issue was. But anyway, we had two club members come out. They were Brian, AA3BK, and Dave, W5QS. And they both did a great job. And we were very much appreciated by the organizers of the event. The race director, said that he was very, very pleased that we were there. Anyway, our next event is going to be Monday, May the 30th, and that's going to be the Radnor Memorial Day Parade. We're going to assemble at the Micro Center parking lot, 550 East Lancaster Avenue, also known as Route 30, Suite C in St. David's, PA, 19087 at 8 o'clock in the morning. And the event runs from approximately 8 a.m. until 12 noon. We'll have informal talk-in on 14706. And this is probably one of our most fun events because it's obviously a parade, and it's actually fairly short. And usually it's a real favorite for pretty much everybody. And you may want to bring an earphone because sometimes it's a bit noisy, but it's usually a good time for everybody. And our third and final public service event for the spring public service event season is going to be on Sunday, June the 12th. That's the Penwyn 5K race. It's held at the Penwyn Elementary School, 250 Haverford Road in Wynwood, PA, 19096. And this event starts at 8 o'clock in the morning and approximately goes to 11:30. And once again, talk-ins on 14706. And this is a 5K race, so it's fairly short, and it's usually a nice event. So it just travels. The racers go through the neighborhoods and so forth, and it's just kind of nice small event. So that's kind of all we have for public service this year. We've had a few events that went away, but that was beyond our control. So anyway, that's pretty much all you have it for public service. All you have.
All right. All right. Thanks, Bob. I want to thank everyone who went out to French Creek. That's a 1 hour drive at the ever popular 0530 or something like that. I like 0530, sounds like it's a lot earlier than it is. And yeah, so the Memorial Day Parade will be this Monday. Hopefully we'll have a really nice turnout for that, because that can be a little challenging in terms of communications. I know we have some noise sources and some terrain, so it's really good to have operators in different areas. And then Sunday, June 12th is the 10 Win Run, which is a nice short event. All right, so Bob, while we've got you on the hot seat, did you want to talk about the Ham Fest?
Yeah, okay. We're going to do the Ham Fest. We now have Ham Fest flyers to hand out, and I guess first of all, I should probably say that our Ham Fest is August 14th, Sunday, August 14th. I believe that's the right date. And yes, Sunday, August 14th. And the setup day will be on Saturday, the 13th. And we're definitely going to need everybody to help out with this event. Kind of like an all hands on deck event, because we really didn't have enough people last year to help out. And I think, fortunately, some people got to man their positions for a little bit longer than they should have. And that would like to avoid that. If we can get enough people to come out to help, then that can be totally avoided. You only have like a two-hour shift for most jobs. And also, we do have some Ham Fest flyers to hand out. We handed some out on the Wrightstown Ham Fest on May 1st. And unfortunately, we missed three Ham Fests so far. One on May 7th in Succossuna, New Jersey, if that's how you pronounce it. And another one in Hagerstown, Maryland on May 12th through 14th. And the Kutztown, I believe it's the Antique Wireless Fest or whatever it is. That was on May 13th and 14th. And I don't think we got anybody to hand out Ham Fest flyers to those. There's two other Ham Fests coming up. Unfortunately, they're on Memorial Day weekend, this weekend. One is on May 28th, which is Saturday. May 28th is Saturday. It's the Washington Township, Bergen County, New Jersey Ham Fest. And the other one is on May 29th, Sunday, May 29th, the West Friendship, Maryland Ham Fest. So if anybody is planning to go to these Ham Fests, let me know, and I'll give you a handful of Ham Fest flyers. We have a new feature this year where we've padded some Ham Fest flyers to make it easier to put them out on the club table and so forth, and they won't blow away or anything. So that's a big innovation for this year. So and if you're not going to a Ham Fest recently, you might consider doing it. It's lots of fun to go to a Ham Fest, and the club really needs your help handing these flyers out. I can't go to all these Ham Fest myself, so I'm going to need lots of help. We also have, let's see, looks like 1, 2, 3, 4, 5, 6, 7. There's seven Ham Fests coming up in June. And so there's 7 more opportunities that you can help out the club to hand out Ham Fest flyers. And so if anybody needs Ham Fest flyers to hand out at a Ham Fest, just call me up, let me know, and we'll get some to you. So that's about all I have, I guess, at the moment for the Ham Fest. Hopefully, as time progresses, we'll get more information about it.
All right.
I have a question.
Thanks, Bob. Yeah.
Bob, can you send me a PDF of the flyer?
You can go to
Um,
the MARC website.
I'll
It's on the
try.
website. You can download it from the website.
Okay, thank you.
You just go to the Hamfest page, and then I think there's a link. It says you can download the flyer here, and I think you click on the here.
Yep.
And that's
Yeah, I use it in the promoting VE testing that day.
okay.
I'd like to bring everybody up to speed on what's happening with fundraising. I put out 123 inquiries to every manufacturer I could come up with. So far, I've had 25 responses back. Mostly they're gift certificates of small amounts. The most expensive thing we've gotten is Penta Labs sent us a matched pair of 572B tubes, retail value $180. So I think that'll probably go out on the club table to be sold, because it's ridiculous to give it to someone who doesn't have a use for it. But we've gotten promises and gift certificates, including that, totaling $693 so far. Not quite as much as I had gotten years past, but I'm still waiting, and it's still early. A couple of them are saying wait until July before they'll send out stuff, and remind us the end of June. So we'll see what happens.
Bob,
Yes.
Steve, K3FZT. I handed out about 30 flyers at the Delaware Valley Historic Radio Club flea market at Renninger's in Kutztown on Friday. I was up there checking out the flea market and giving away a 1928 Colonial radio, and I handed out the 30 flyers I had.
Okay, great. Thank you.
Bob, it's Dennis here. I'm going to Harrisburg on the 2nd of July, and I have the flyers.
Okay. Yeah, you have enough from Wrightstown?
Yeah, I printed more.
Okay.
All right. Thanks all. Actually, Steve, while you're on here, did you have anything that you wanted to say about the Fusion Gateway? Because Dennis and I talked it up a little bit, but if you wanted to say anything, you're welcome to.
Well, you saw my photos.
Yeah, I showed those.
So the point is that I've got all the hardware in hand, and I'm just waiting for my neighbor contractor to give me half a day's work on antennas, and I'll be ready to go. I've surveyed the path. It's a clear path, and I'm looking forward to putting up a full-time Wires X C4 FM gateway on, you'll correct me if I get the frequency wrong, 444.050.
That's correct.
So, the club has agreed to offer some support, which will probably end up going to defraying some of the expense of the contractor who puts up the antennas, because the hardware is all in hand at this point. I've made certain decisions without consulting others, but for example, the computer runs on 12 volts, as do the radios. So at some point down the line, if we ever made a decision as a club that emergency powered operation was important, it could all operate from 12 volts and battery and solar power. I've done my best in planning this to be both prepared for current operations, but also thinking about what the future might hold.
All right. Thanks so much, Steve.
Steve, that's good to know because 444050 at Darby is on a motor generator set of the hospital, so it will have emergency power. It's had it for 35 years.
So again, that's I knew that, Dennis, because that's on the website. Thank you for reminding me of it. And that was what drove me, along with my experience of putting up a WinLink gateway in which emergency power is highly valued, not required, but is a valuable adjunct. And like I say, I'm not prepared to put up a battery and failover and all the rest of that at the current time. But at some time in the future, if the club decides that's important, that could be doable. I did not include a photo of where I intended to locate the equipment, which will be in the basement directly under my feet in my ham shack. And so it will have access to the same pathways to the antenna, to ground, and so forth.
All right. Thanks very much. We're looking forward to having that, and we're glad that Steve has taken the initiative to volunteer to host the gateway at his site, which is going to be really nice thing because that'll add to the capabilities of our repeaters.
WQ3Z.
Yeah, go ahead.
Was that for WQ3Z?
No. Yeah, I wanted to thank Bob and Rich for all their leadership with the Ham Fest. So let's jump ahead a little bit. VE team.
Query from WQ3Z.
Yeah, go ahead.
Was that go ahead for WQ3Z? I'm in the car.
No.
No, I'm saying, does WQ3Z have the floor?
Yes.
Ask a question.
Yeah, go ahead.
Again, I don't know if you're talking to me or somebody else because I can't see the screen.
No, nobody said anything to you.
No, I've got three things about the Ham Fest.
Oh, okay. Yeah, go ahead with your stuff in the Ham Fest.
So, I was expecting that procedure of go ahead WQ3Z. That said, one, Bob, remember the magnet. Don't forget, I've got the magnets, okay?
Okay.
Two, what time is set up on Saturday?
12 noon.
12, so it'll be an afternoon setup.
Yep.
And three, Rich, great job on getting the prizes. I'm just thinking for anything specific like that, rather than picking a name and saying, you've won this, for stuff. Now, granted, we're not going to be giving away, we're going to be selling the tubes, but anything specific like that lets people pick, okay, here, there's 5 items left, pick one, because I went to a different event where they were doing that. And it's like, I don't want, they said, you've won this. I don't want that. I want this. So I had to wait around for the next person and trade with them. But,
Yeah, we'll take it under consideration.
So thank you. That said, great job. And I'm glad I'm not going to win the tubes I can't use. Jeremy, back to net control, WQ3Z.
All right. Thanks, Ned. All right. How about VE team? Dick, you have an update?
Yes, I do, as a matter of fact. Hold on a second. My mouse rolled off the arm of the chair here and lost my screen altogether. All right. We had a session on May the 7th, a little over 2 weeks ago. Very successful. Everybody passed. We had 2 new technicians, 2 upgraded to general, and 1 upgraded to extra. And by the way, the extra person had a 100% correct score. Very impressive. No one failed. And we served 5 candidates and 5 elements were administered. Ron, W3RFX, upgraded to extra. Mike, N3QLZ, upgraded to general. And by the way, he's a MARC member, so he didn't have to pay. Alston's a new tech from Philadelphia. Ian is a new tech from Reading. And Robert, KC3TZQ, upgraded to general. So VEs are participating, were W3ZQN, K3DS, N3OMR, AA3BK, and myself, K3ITH. Our next scheduled VE session is Saturday, August the 6th at the Lower Providence Township Building in Eagleville. Back to you, Jeremy. Any questions?
All right.
Yeah, I have a question.
Yeah, go ahead.
Are we going to have one at the, we're going to have a VE session at the Hamfest?
It's
Yes.
my intent to have a VE session at the Hamfest on
Thank you.
the 14th of August, I think the date was. I'll get that published in the ARRL VE list.
I assumed you would. I just wanted to confirm.
Right.
All right.
Thank you.
Are you available, Brian?
I hope so.
Good. We usually get a pretty good turnout at the Hamfest.
And I try to help.
All right, thank you, and congratulations to the 5 who got new licenses or upgraded, and thank you to all those who helped out with the session. So we have also resumed breakfasts in the last couple of months. The next one will be coming up on June 11th. Did anyone want to give a report on the last breakfast?
Yeah, I'll give a report. We had a 25% increase in the amount of people that came out for the last breakfast, which meant we went from 4 to 5. So, but it is going in the right direction. We had a great time, good fellowship. As I said in the circulating email, too many Zoom meetings. It'd be nice to get together on occasion. What's better than having a really great breakfast? So look forward to the second Saturday of June, which will be our next scheduled one. It's on the website.
All right, thanks. Yeah, that'll be June 11th, which is the day before our public service event on the 12th. A couple quickies. Nets are continuing to take place. Days and Sundays, 8:30 p.m. The numbers of check-ins have been down a little bit in the last couple of weeks, so hopefully we'll be able to bring that up. I think sometimes the summer, the numbers are down a little bit because people are out. You know, the sun is like actually still up at like 8 o'clock, so people might be out doing things. So usually the summer is a little bit slow, but hopefully we'll get some nice check-ins and also give Dennis some data to check out that repeater. As far as field day, Jim W3JNF was called into a late work meeting. Apparently some folks in California were having a late afternoon meeting. So he's not here yet, but if he gets in, I will give him a chance to talk. But for field day, we're on for the Lower Providence Fairgrounds, June 25 to 26. That's the 4th weekend in June. So we are planning to have a full field day. We're going to have the merit badge session for the Scouts. I was actually just in touch with the Scout leadership, and we're getting the event publicized with them. And I don't know if you can hear the ice cream truck outside. Must be summer. So we are going to do the Scout merit badge session, and I'm expecting that will fill up very quickly because there's probably a lot of people who want to do that. Other than that, I will let Jim give any updates on what's going to be coming. So I'm assuming we're going to be doing a fairly normal field day operation, probably 2 alpha or 3 alpha with a GOTA station. I will be doing the emergency power, all that usual stuff. So maybe we'll have an update from him a little bit later. All right, I think that's it for club business. Did anyone have anything else to add before we go to our presentation?
Our meeting for June, what date is that?
Good question. Actually, I should mention that. Normally our meetings would be on the fourth Tuesday, but for June, we're going to plan to talk about Field Day. And given the nature of time, it makes more sense to have the meeting beforehand if it's planning for Field Day. So I believe it's June 21st, which will be Tuesday. And of course, we can do that because it'll be on Zoom. So we'll meet on that Tuesday to discuss more specific plans for Field Day. And then that Saturday, we'll be out at the Field Day site. So thanks, good question. So yeah,
I'll update the
21st.
calendar too, Jeremy.
Okay. Yeah, I think I sent out an email to the board. Did everybody get it?
Yes, I did. Yep.
Okay.
Yep.
So June 21st will be the next meeting, and it'll be discussion of Field Day. And I saw a check in on YouTube, Ryan KC3DLL, welcome aboard. Any other club business before we go to the presentation?
For the June meeting discussing Field Day, I'll whip up the pictures of past Field Days. And always nice to see some archive pictures, so we'll have something
Okay.
to look at too.
All right, thanks. That'll be great. Okay, so let's move on to our presentation. So tonight we're very happy to have our very own Dr. Dennis Salage, K3DS, and he will be talking about antenna modeling using EZ-NEC. So take it away, Dennis.
You muted, Dennis.
And it's the next problem. Let's say screen share. Hello. Go here, say share. Okay. So the PowerPoints are up. What's the point? Let's do it. Come on. Okay. Hopefully you can see the PowerPoints. Everybody can
Yes.
see that anyway. I'll put this up here. All right. This is kind of interesting because this particular program has been around for a while. And if you don't know about it, it's free now, which is really good because in the past, they did have a demo version, which was reasonably a good introduction, but the fellow did want you to get a license and use it. But now I guess he's now turning it over to general amateur use for free. The website's still up. You can download the version 7 software, which I'll show you in real time at the end here. There's a 237-page manual that goes along with the software. So obviously it does quite a lot of things. But the thesis of the talk is that one can do antenna modeling using this program without sitting there and cutting wires and throwing them up in the air and stuff like that. And antennas are basically the last vestige of amateur radio experimentation because they're we can't really do too much with our radios anymore, especially if you have a high performance rig. Everything is a black box essentially, but antennas are still one thing that are still out there and still something that we can play with. So it's the program is called EZ-NEC, and we'll have a little bit to say about the historical basis for it and things like that. So the historical basis for EZ-NEC actually goes back to your tax dollars at work. Program is called Numerical Electromagnetics Code, developed by Naval Ocean Systems Center in San Diego. The full-blown version was never released to the public, but it was based upon the method of moments section having to do with the solution of antennas, where you break it up into pieces and you summate the response. But what they did release in 1982 to the public was this technical document that you see here, which I happen to get a copy of, which was called Mini-NEC. And what Mini-NEC was, it was a DOS program, very early computers, of course, written in GWiz Basic, so Interpreter Basic, and didn't have anything in the way of graphics as we're going to see tonight. It had keyboard input and output, but it did run the modified versions of the NEC called Mini-NEC. The reason why the Naval Ocean Systems Center was interested in this was at the time, and still probably currently, wire antennas on major naval vessels were prevalent, and they could model, basically stringing wire antennas across the masts and inverted V's on the battleship and things like that. So that's what they really got involved with, the development of it through the 70s, and then the releasing of it in 1982 to the general public. So as I said, you can start with that as a premise, but all the heavy lifting's been pretty much done. Okay. So I actually got a hold of this about this time, and my computer at home, although I did have an IBM PC, but I wanted to see it run on my Apple II. So I typed in GWiz Basic into Apple Basic to model a simple dipole antenna. And if you're not familiar with the Apple II, it was a 1 megahertz. Yes, that's not 1 gigahertz. That's 1 megahertz 8-bit microprocessor. And it does not have a floating point processor. Floating point processor means it knows how to multiply and divide. So basically, it took a long time to do things. So even a simple dipole antenna took about 2 hours to compute. Well, it's a home computer. Who cares? 2 hours. Get a cup of coffee and come back. But I actually had a little bit better thoughts about using this program. And what I did do when I joined the faculty at Temple University was I modified it to run on a mini computer, a PDP, I'm sorry, not a PDP, VAX 750, which is a PDP 11 in a box. It's a 3 megahertz computer, but it did have floating point, but it's also relatively efficient because it's 32 bits and not 8 bits, and it did have a floating point processor. So the same dipole antenna simulation that used to take 2 hours got done in about 1 minute. And also shown here is a lab experiment from the course I was teaching called Electromagnetic Waves and Propagation. And as you can see, it was very early on. So it's a dot matrix printer here and hand-drawn graphics and all that in a Xerox machine. It was very primitive when we were teaching back then. But this particular one was some sort of a dipole that's now brought in a certain angle. That's what L1 and L2 is supposed to be. And basically starting with a full halfway dipole that resonates. All the students have different lengths and stuff like that. Bring it together at an arbitrary angle. The student has a different angle, find out what the resonant frequency is. And then for the second part, once you get done, put a reflector back there, see if you can get a little better performance out of it. So it was certainly one way to make antenna design come to life a little bit, because otherwise it was kind of a boring topic. Basically all just pencil and paper, those kinds of things. But when you do simulation, you can get a lot out of it. So if we fast forward from this era, this was 1986. If we fast forward to this era, we now do it on our home PCs and have a lot of fun. So MiniNEC has been kicking around for a while. It was popularized by a couple of people, but among others, this fellow Roy, W7EL, and he basically improved MiniNEC, converting it to run on a PC with floating point processor, but also adding a graphical user interface so you can see what you're doing and get plots and things like that. Originally, he goes back a long time with it too. Originally, it was called LNEC, I guess that's what it was called, W7EL, around 1990, but then for whatever reason, he changed it to EasyNEC. And this website is still up at the moment, www.easynec.com, which is where you can go and download the version 7 software for free. And I guess as long as he has it up, you might want to do it sooner than later. After that particular introduction of simulation software for antenna design, there were a lot of QST and also QEX. If you're not familiar with QEX, QEX is the technical journal that the week puts out. But even in QST, here's a technical correspondence page from February 1991 from QST. So you can model these inverted V antennas and things like that as a practical aspect for antenna performance. And primarily the goal here was to have the simulation replace your tedious construction. It's nothing like cutting wire, setting it up, and then finding out it doesn't resonate, right? So you can give at least the first shot at it by trying to do a simulation first, and then see what it's actually going on. Okay, so how do we do this modeling? Well, it's not as easy as you think, because there's a little bit of work that has to be done. So antenna modeling in NEC requires breaking up the wires into segments, if you will. So here's a typical ground plane antenna. So for ground plane shown, there are 4 wires. You have to identify those 4 wires, and not in a way that, as I'll show you, is a tabular list. So you identify the 4 wires, and then you break each one of these wires into segments. But in order to do that, you have to specify the X and Y and Z locations of all the segments. Essentially, you're going to be doing a lot of pencil and paper drawing and graphics and calculating in order to get the antenna set up. But it's not too bad once it's done, and you can do a lot with it once it is done. So this is a ground plane antenna. These are the radials down here. That little circle there indicates where I'm going to put the load, where I'm going to put the source that comes in. And we can model this with whatever frequency we want. And we can take a look at whether we need 3 ground planes or 4 or whatever. So there's a lot that can be done without actually cutting wires and setting it up. Complex wire antennas can be modeled because, as I said, you can really do a lot with EasyNet once you get into it. So if simple ground plane antenna, not a particular problem. But here's a little bit more complicated antenna. These are like loading coils. They're essentially loading coils at these locations on sort of a dipole antenna so that you can get a multi-band dipole antenna out of it. The other drawings that you see are supposed to indicate what the currents look like on this particular antenna. So the antenna's in green and the Cartesian coordinates X, Y, and Z are in red, but we're going to see that in real time at the end anyway. Okay. Now, you might have to be somewhat dedicated to use the program. As I said, it's not exactly cut and paste, but after all, it's something that you can really get into because antennas and their operation and their capabilities are something that I think we're all interested in. So over the years, ARL has had QST articles that have appeared. So here's an example of a part 1 story, a beginner's guide to modeling with NEC, and these are available on the ARL website. There's ARL.org antenna-modeling has a compendium of all these different past articles and things like that. So the article reads are very straightforward and basically teach you how to use EasyNet in this case, or any version of the electromagnetic codes. There were a couple different versions by a couple different people. Now, what we're going to see is something that you have seen probably printed in a magazine, but we're going to measure field strength measurements at distances which are what's called far fields, which means greater than 10 wavelengths from the actual antenna. So here's a piece of paper that in the past we used to sit there and do these far field measurements by hand by running around in a field somewhere with a field strength meter, but now we're going to be doing it in simulation essentially. So we have 2 types of field strength measurements, but we're also going to see a 3D plot. But if you take a 3D plot, which looks like a sausage, and then cut it, we can cut it horizontally or in the azimuth direction. So you can see what it would look like it was propagating horizontally to the ground. Or you can also look at the vertical elevation, but you can also look at the 3D elevation, or even a 2D elevation cut through the sausage so you can see what the angle of attack is and how the antenna takes off. You can also model ground, how far it is above ground, the type of ground that you're using, and also the type of wires and whether the wires are a certain size and have losses and things like that. So it's a pretty elaborate program if you really want to get into it. But all of the good articles that you see in QST when people propose this, that, or another thing, they'll usually back up their design work with some simulations, and that's where it comes from. So basically, it does have applications in practice. Okay, although shown in various prior editions of ARL antenna books, amateurs were then presented with these vertical and horizontal so-called E-field, stands for electric field, patterns for antennas in QST. Antenna consists of 2 patterns. It's called electromagnetic, so there's an electric field and a magnetic field, but for normal purposes of calculation, we consider the E field because it's the E field that induces currents to flow on a receiving antenna, and it's currents flowing on the transmitting antenna that generates the E field along with the magnetic field. But these are typical plots of what you would see in QST, for example, and in the antenna book quite extensively. So recent editions of the antenna book have had many examples of EasyNet, and so, in fact, some editions of the antenna book actually had CD-ROMs with demo versions of NEC sitting in the back of it. Here's a little historical version, the ARL antenna book from a long time ago for 50 cents, and then, of course, the more current editions. So this is what NEC looks like. This is actually version 5. I didn't put the newest version version 7 pictures because they look pretty similar. So we'll see what that looks like in real time. But in this case, this is version 5, the demo version, no less. And here is the antenna that we're modeling. We're modeling a 5-element Yagi. I see 5 solid wires. This shows the cut of the E-field propagation for this particular antenna. We can see what the angle is. It might be so many feet above ground. We could see the 3D plot right here, and we could see the cut of the sausage or the 3D plot in red, which is what we see as a 2D plot over here, or we could see the E-field plot over here, where you can get readings like what the gain of the antenna was. So this particular antenna, 5-element Yagi, has a gain of about 15 dB maximum gain at an angle going off at about 12 degrees or so with respect to the environment that it's operating in. So the point is, it's a lot easier to do something like this than to try to do something with cutting and pasting wires out in the field. Of course, a 5-element Yagi you might want to just buy, but it's also good to see if you even bought one to model it to see what the performance might be and not really believe the manufacturer. So the EZNEC 3D display of the far field pattern of, again, of this 5-element 14 megahertz Yagi can be shown as a 2D slice, and I'll be showing you that. So you can see what it looks like, and basically this shows what the direction of propagation and also the front to back ratio might be. So going back here, for example, I could see what the antenna is behaving off the back of the antenna, how good the front to back ratio might be, for example. Okay. So you can take any slices you want. You can get detailed information of any horizontal or vertical slice that you want, azimuth or elevation, if you will. And you can get performance metrics having to do with the match, frontal lobe, side lobes, beam widths, and all kinds of other important information about the performance of the antenna. So in order to use EZNEC, you're going to get a design screen, and the design screen, as I said, is not going to be overly useful because you're going to have to design the antenna with pencil and paper, selecting how long it is, where do you want to put the wires, their X, Y, and Z location, the number of sections. And then from there, you have to enter that information. You can also bring in a file, but you can enter it directly into each one of these possibilities. You can give it a frequency of operation, tell it how many wires it has, for example. In this case, this wire has 2 wires with 12 segments, which means how many pieces I break the wire up. It's going to have a balance source, so it has not just a coaxial feed, it will have a balance feed, so that's what they call 2 sources, 180 degrees apart. You can put loads on the antenna, which means basically you can make a Beveridge type antenna if you want. You can also model the transmission lines. You can model the wire losses. In this case, we say 0, but you could put actual real wire thickness in there and get the performance metrics on the design of the antenna. After you do that and everything is okay, you can say view antenna, which I'm going to show you in real time. So you can get a view of what the antenna might look like. This happens to be a cardioid antenna with 2 wires. I see wire 1 and wire 2 spaced apart along the x-axis, and these show the currents flowing on it. That's why it has 2 sources. So it's basically 2 vertical antennas, a steerable array type antenna. But that's what the antenna pattern would look like if you say view antenna, which we'll see in real time. Now you can rotate this. You can rotate the display, take a look at different angles of it, upside down, backwards, or whatever you want. And that goes fairly quickly on a reasonably performing computer, PC. You get a whole bunch of source data about excitation. You can certainly get reflected power and things like that, the SWR and things like that. Both at 50 and 75 ohms, you can also specify other characteristic impedance of your transmission lines too. I like the SWR sweeps because that tells me basically how the antenna is performing, and if it's not performing in the band that I'm interested in, why isn't it doing that? So you can specify start and stop frequencies and also the frequency step and tell it to run for an SWR plot of your particular design. This happens to be about a 300 megahertz ground plane. And you can get a sweep like this, not doing very well at 50 ohms, as you can see, about 3-to-1 SWR pretty much across the range. And you can also get the antenna pattern, if you will, as we said before, and that's called the far field plot. Okay, so there's a couple different designs that we can look at. I'm going to be looking at a very popular antenna that's often misunderstood, and that's an inverted V antenna. Dipole antennas will do it first because it's the easiest to see, and then we'll take a look at an inverted V antenna. And when you download EasyNet, there's actually some examples that are already given. It's about 25 different examples that are already preloaded. So it gives you a place to start. And this backyard backyard V antenna is one of their examples, as it turns out. And that's what it looks like, a typical inverted V antenna sitting at a height above ground, which we're going to play with, in fact, because in the real-time simulation, where we can add some sort of a real ground, and also height above ground, which really affects antenna performance a lot.
No,
Okay. So 2D backyard plot of the inverted V tells you the angle of attack and that sort of thing. Specifying the frequency of operation where you might want to have it run. I got it at 14070, which is the digital PSK frequency, if you will, if you want to put something like that up. And this is the hard part. This is what you're going to have to do pretty much by hand. And we'll take a look at that in the real-time simulation. This is called the wires. Wires is one of the boxes that you check, and you have to specify the X, Y, and Z location. And you can specify, in this case, we only have 2 wires because it's straightforward dipole antenna. So we have 2 wires, X, Y, and Z. Z is the height above ground, essentially. You can specify the wire size, like number 12 wire or anything you happen to be using, and how many sections you have. This is probably the hardest part about EasyNet, is just coming up with a rough estimate of what the layout would be, but it's what we used to call geometry, right? So getting the geometry down is half the battle. But the good news is you are going to get plot displays. So if you screw up on the geometry, it's going to be very apparent that you screwed up on the geometry because the plot won't look right. Okay. So you could put the sources at any particular location with any particular polarity or any kind of nominal value, like 1 volt or something like that, and specify different transmission lines, wire types, and things like that. So the capabilities are much more elaborate than what we're even going to show here tonight. But again, it's something to play with for sure. What I like to play with a lot is ground, because we're going to do a couple of different tests here to show you what's going on. We'll do at least free space, which means the antenna exists without any ground effects at all. So it's sitting out in the middle of nowhere in free space. Or we're going to put it above real ground, and they have some capabilities of putting different properties of ground, whether it's good soil, bad soil, things like that. That's all described in the manual, where you can specify what the real ground might look like. So we'll take a look at what that does to it in a real antenna too, for that matter. And then of course we get the SWR plot, and this was not performing too well, of course, at 50 ohms anyway. Okay, so I'm done with the PowerPoints. What's the point? Let's see if I can get rid of that and bring up the demo. Can you still see my screen? Or now I got to change? I have to change. I got to change.
On the PowerPoint.
Yeah. Come on. Trying to figure out how to get back to the share screen thing. Oh, come on. No, that's not it. There it is. New share. Go to this share. Okay, so now you should see my desktop anyway.
No, I think there it is.
You got it?
You got it now.
Okay, good. So what I got running on the desktop is a couple of different tiles from EasyNet Pro version 7. And we have a couple of different screens up here. So we'll start off with the dipole. And of course, whenever one does a demo, it never works for the general. So here's an example of that. So this is the backyard dipole graphics over here. And it's a nominal 14 megahertz, but it's a little long for 14 megahertz. We have a back of the envelope formula that says a dipole in free space is 468 divided by frequency in megahertz. And it turns out it's not going to be 70 feet. You can do meters if you want, but if you want to be English about it, you can convert the units to feet. If you click units, you can go to meters or millimeters or whatever you want. You can even do it in wavelengths if you want to do that, but we'll just leave it as feet for now. So what I have is I've got this dipole and I've got it sitting out nominally, this is the wire screen over here. You can see it's at an elevation of 20 feet above the ground, and it runs from 0, 0, which is this point right here on the z-axis. Got to remember your plane geometry and your geometry, three-dimensional geometry. And it's 20 feet up in the z-axis. And then it goes out 33 feet, which is half wave of what we specified for the wave, for the frequency that we would like it to work at. And again, at 20 feet. So it looks like a conventional dipole with the source right there in the middle. So you go back to this screen here, which is your sort of your command center. And we can put ground type free space, which I have. And I'm going to say, give me the SWR, and I can specify, let me scan from 3.5 to 14.75 every 0.05 megahertz. And I say run, and I have a pretty fast machine here. So that's done already. So I want to show you a couple things that might be of interest to you. One is I'm running this at 75 ohms. For this particular design, I can basically move along here. You can see these numbers changing as I move the operation point. So I moved to the minimum VISWAR point, SWR point, and it's resonating at 14.3 megahertz, and a VISWAR very low, 1.04, which is immaterial almost. And I'm running it at 75 ohms. Now, the dipoles, we are running in free space. The theoretical characteristic impedance of a dipole is actually 73 ohms. So running it at 75 ohms, coax is our closest best fit, and that's what we tend to run it at. But a lot of people say, oh, I don't have any 75 ohm coax. I'm going to run my dipole at 50 ohms. So here's what happens when you run it at 50 ohms. The resonant frequency shifted a little bit. It went down to 14.25 megahertz, and the VISR went up to 1.44. Now, if you're okay with that, or if that's what you want to operate at, then fine. Then at least you have a rough idea, you know what's going to happen when you start doing something like changing the coax feed from 75 to 50. So that's kind of interesting, and certainly confirms what's going on. Again, this is a free space dipole. So let's go to ground type, and let's go to reel, and we'll do the mini neck reel, which is the specification that I put in for typical soil around here, which is a loamy type soil, not exactly sand or anything like that. And I'll say, okay. And if I say, give me, so now we've done a reel ground. Ground type is now reel or specified. And I'm going to do VISWAR again, and I'll scan again. Of course, we can try to predict what's going to happen. So here is the 75 ohm plot. So now I have a dipole, conventional dipole antenna. I haven't cut any wires or done anything, but I know I'm going to put it about 20 feet up in the air. And I find out that this particular antenna is not going to perform like a free space antenna. In fact, the resonant frequency dropped from 14.3 down to 14.1 megahertz at 75 ohms, and not a very good match, 1.21 VISWAR. And what the reason for that is that one gets an image of another dipole that's below, essentially on the other side of whether ground or not ground, if you will. In this case, with ground, you get an image, and that causes the antenna not to perform as though it's in free space. So that's good in the sense that you didn't have to cut any wires and do anything, but you're going to know that your antenna at only 20 feet high is going to do that with 75 ohm feed. How about a 50 ohm feed? Well, it's not going to do so well. It's going to be about 1.82 at about the same resonant frequency. So that gives you a lot of quick numbers that you can use in your design work. Well, you could say, well, gee, I'm going to try to get up a little higher. And without worrying about climbing a tree or something, let's go up to, how do we get to make it higher? Well, we go over here to wires. That's what I said about, you got to know your plane geometry, your solid geometry. So let's see, it's 20, let's go to 40 feet. I'll really get it in the air. And go to 40 feet like that. And the antenna has jumped up. So we're running 40 feet high, if you will. And let's run our VISWAR plot again. SWR plot over the same frequency range, but now it's 40 feet in the air. So you can see what happened at 75 ohms, the resonance has moved higher again, like it was in free space. Not exactly like in free space, but certainly not as when it was at 20 feet. 14.35 megahertz, about 1.3 to 1 VISWAR. You don't, surprisingly, when this is a surprising result. So I'm running 75 ohm coax at 40 feet high. And I have a antenna that's giving me about a 1.3 to 1 VISWAR at 14.35 megahertz, just about out of band. But if I go to 50 ohms, which nobody says you should do because the dipole is supposed to be 75 ohms nominally, the VISWAR improves to 1.16. So that's really an interesting finding just by having it really high up in the air. And of course, if you're not blessed with tall trees or poles or anything, maybe we're going to try to do, I don't know, let's pick a number. Let's pick a really bad number, like 10 feet up in the air. So we'll do 10 feet up in the air real quick. See, the good news is I'm not changing X and Y locations. I'm just raising and lowering the plot, if you will. There's the antenna. Now I hit VISWAR. Now down at about 10 feet above the ground. Everybody can try to predict what's going to happen. Well, at 75 ohms, it's going to do that. Again, it's not going to perform well with 75 ohms. Low dipole antennas are not going to perform well. That's what the simulation is showing. So you might as well save your money, not buy the 75 ohm coax and just go with the 50 ohm coax. At least the VISWAR will be better. And of course, the resonant frequency is down around 14 megahertz. So the point is I could play now at this point, which I'm not going to try to do in real time, but I can play by changing the lengths, for example, and the feed points and all that other stuff, and essentially come up with a new antenna and change the design and stuff like that. So that's what EasyNet basically buys for you. Now, what we did say is that there are these other plots, and here is the idea of the three-dimensional plot, if you will. So here's the azimuth slice. I don't know what's going on. It's not, no, try the elevation slice maybe. And let's try to whip it around a little bit. So that's showing what the antenna is performing really low on the ground. It's basically not doing anything, what you would expect. The 2D plot looks like this. So when it's really low to the ground, you don't get a very good takeoff angle at all. You basically are shooting straight up in the air. So again, it's a confirmation of what you can do and can't do with antennas of different types. So that's the classical dipole antenna, and it's really a strong function of where you plan to mount it with respect to ground. So let's look at, for all it's worth, let's look at the backyard. Let's say no, but let's go. This is the folder with the various antennas that are provided for free. So I want to go to the backyard. Where's the inverted V? Here it is, backyard V antenna. I'll go with that. Say open. So here's the antenna that we saw before, a classical backyard V antenna, supposedly running at about 14 megahertz, a little bit more complicated X, Y, and Z locations, as you can see, because you have to specify the endpoints of the antenna, essentially. So you get both, you get Y components now, for example. But everything else remains about the same. Let's see, let's go back to ground. Let's go back to free space first, see if the free space performance is anything to write home about. View antenna, fine. Let's go to SWR, pick the frequency again, go about 13.5 to say about 14.75, and step size about 0.05, something like that. And then say run. And this is what we get. So our first attempt at the free space antenna, not too good, but we wouldn't be operating in a free space anyway. So the resonant frequency is way out there. It's up about 14.6 megahertz, not overly resonant because it is an inverted V. Inverted Vs are basically compromised antennas designed to make the antenna basically operate at relatively low positions above ground. So let's go then to ground type instead of free space. Let's go to real and mini neck for that matter. Go like that. And let's change the, well, the dimension out. We've got about, we've got the Z locations you can see right here, 33.94 for whatever reason above ground. So it's about 33 feet above the ground. There is obviously, if you try to lower the Z locations, you're going to get a warning message if these antennas touch the ground, right? Because they're not supposed to touch the ground. So we'll leave it at 33.94, roughly 34 feet above the ground or so to the location where the inverted V is. And let's see what happens now. Let's see, we've got the real and we've got that. Okay, so let's go VISWAR. And the range is okay, hit run. And I'm not really winning too well. That's the 50 ohm plot. Well, I can't may not want to run it on 50 ohms. Do I want to run it on 75? Doesn't seem to perform any better. So this particular antenna, the way it's designed right now, is not performing very well at all. So what you do at this point is you begin to doing the types of cutting that you would do instead of cutting wire and then losing that forever. You can just change the dimensionality of the antenna right here on the screen, and you can watch the resonance move. So this was at one particular location, if you will. Let's see what else we can do with this easily. Let's get the 2D plot. So here's a typical inverted V antenna, which obviously is performing a little bit better as far as the takeoff angle is concerned. We can also get rid of this and do the type of plot. Say ground wave, ground description. What is that plot? Oh, here it is, plot type. We can go 3-dimensional, okay, and view antenna and look at the plot. So here's the 3D plot with the azimuth and the elevation slight. The elevation is what we normally look at because it talks about how the antenna can take off. And we can rotate it, see what it would look like off the sides, for example, what the performance would be off the sides, what the performance is, front to back, it's pretty symmetrical, so that's okay too. But that's what the elevation slice would look like. So basically the takeoff angle. You can also do the 2D plot, and that's what the 2D plot looks like. So that little sausage cut in red is the same one that we have here. So it does about 6 dB a gain, and let's see what else. Front to side lobes, that sort of thing. Cursor elevation gains about 6 dB or so. So that's the inverted V antenna. The other one we could look at, but again, there's so many to play with, so little time. Let's just go with one more. Say no. And that was the so-called field day special. I don't know how special it was. It didn't seem to be performing that well. Say field day special, FDSP, field day special. It's a 2-wire antenna. Here it is here in the display. 2-wire antenna running nominally at 14 megahertz or so. Here's the different dimensionalities. Right now we're sitting about 40 feet above ground, so we'll play with that. So let's leave it above real ground, ground type real, fine. Okay, I guess that's all right. Let's try that. And let's try SWR. Again, we got to set our range because we want a range of SWRs to see where it might resonate. Let's go to, again, below the band, 13.5, and above the band, say 14.75, followed by a step size of about 0.05. Fun with Dick and Jane. Okay, goes like that. Okay, so this particular field day antenna is resonating outside the band with 50 ohm feed, and with 75 ohm feed, even worse. So at this point, you have to play with the overall dimensionalities of the antennas. I'm not going to do that because you get into a lot of trouble real quickly. You have to calculate what they would have to be and that sort of thing. And sometimes it gets a little hairy, but you're going to have to do that with pencil and paper and trig, if you will, in order to set these up properly. I wish there was a better way to do it, like you could just draw the antenna and would figure it out, but this version doesn't do that. I don't know of any version that actually does, tell you the truth. They always want you to input the dimensions, and what they do is they take those dimensions and just plot it. So the reverse, where you can have the plot develop the dimensions, doesn't exist in any version that I've ever seen. Maybe I'm not up on every version, but that's certainly not this version anyway. So that's basically Easy Neck, and I guess the real takeaway from this is that it's free. And if it's free, it can't be bad because it is free, but it does work and allows you at least to play around with popular antennas. And I would say certainly the inverted V antenna is a very popular antenna. You can also add loading networks and change it into a multi-band inverted V antenna, that sort of thing, and continue from there. I guess that's about it. Any questions?
All right, thanks, Dennis.
Dennis, this is Alan.
Yeah.
First of all, thank you very much. This is very informative. Last time I checked, EasyNet was only ported to Windows machines. Are you aware of any plans or any other similar products that might be available for the Mac?
Last time I owned a Mac, it was a Mac 1 with a black and white screen, and I had it for 6 months and got rid of it. The answer is I'm not, I don't really know.
Okay. Thank you.
There'd be no reason why it couldn't be. Did you try doing a Google search?
A while back I did, but not recently.
I'm going to do it for you real quick. Mini neck, let's try that. Mini neck on Mac. MacBook, close enough, right? It doesn't seem to be. Okay, but anyway, that's certainly what you'd have to do, Alan.
There's a question there, and there was a forum question there.
Okay.
Mini-net on Mac.
Yeah, well, I didn't spend too much time. It said minute something else. Yeah, forum. Probably somebody was asking, does anybody have it? It runs fine. But there's a whole bunch of antennas to play with, all kinds of different wire antennas. You can rotate this scene, you can make it look really nice if you want. Rotate it around. Dude, that kind of graphics seems to be pretty good. You get some good play of what the antennas would look like and things like that. But I thought it was interesting just to see how a classical dipole behaves, because we always like to throw up dipoles, and now we can actually check the nominal performance of the antenna without actually cutting wires and stringing it in trees, just to see what the resonance would be and how you might want to tune it a little bit before you put it up.
Dennis?
Yeah.
Steve, K3XZT.
Yes, Steve.
Does EasyNet model beverage antennas or terminated antennas with a resistor?
Well, it does have the possibility of putting loads on it. I'm trying to see if it appears in the list of antennas that are here. This is version 7. I don't see anything that looks it, but you can certainly do that, because what you have available is what they call loads. Let's see, where is it? Loads right here. So in this case, I have no loads, but you can specify a terminating load. And you could put it at the end of a wire. You can have the wire sloping. You can do whatever you want to do. So the answer to your question, I believe, is yes. It should be capable of simulating it.
Thank you.
Dennis,
Yeah,
Dennis,
I was just looking at the
one of
manual.
these charts. Go ahead, whoever was talking.
I said I just quickly looked at the EasyNet manual. It looks like there is something about modeling beverage antennas.
yeah, all 237 pages.
RTFM.
All 237 pages of it. Yeah.
Yeah.
It does an interesting thing. Here's a log periodic antenna that it has as one of its given models. You can see how complicated the wiring diagram looks, though, after a while, because you have to specify all the different sections and that sort of thing. But as I said, you have to lay out all that stuff ahead of time and come up with where those points are, and then enter it into a table like this. But once that happens, you can see it graphically, and then you're almost ready to go at that point. So this is supposed to be a nominal 21 megahertz. It says 17 to 10 meter per ARL antenna book. Well, let's just see what it's doing. Let's see, free space. Now let's make it real. Okay. And see, the first thing it told me was that these are touching ground. So can't do it. You're going to have to change all of the Z location so that it doesn't touch ground. So can't do that. So what's the use of having it, right? So let's go back to free space. So it's happier with free space. Okay. Let's see, what can we get out of free space out of it? Well, let's look at the plot. So that's what the log periodic looks like at this particular frequency, which is frequency right here, 21 megahertz. That's what the 21 megahertz plot of the log periodic looks like. Okay.
Question, Dennis?
Yeah.
On this chart, the gains listed, is that with respect to Isotropic antenna?
Yeah, DBI. In
Oh,
fact,
it's DBI?
yeah, a DB reference to isotropic, DBI.
Oh, DBI, okay. Got it.
If you don't know what an isotropic antenna is, Brian was mentioning that the isotropic means a point source, one that radiates in all directions, equally badly, but at least that's the reference that we use on occasion.
Yeah, I know what it is. I just wanted to.
No, you know what it is, but there are other people.
Okay.
Okay. But it's kind of fun. It is free. Even the demo version that was available for a while, demo version 5, is still up there. And it was even better that he was putting it out there for free as a demo. And that would actually do a few things, no problem. Now he's giving away the whole 9 yards.
Dennis, here's a question, possibly a stupid one. What about modeling mobile antennas? Then your ground plane, well, it's not really a plane, it's kind of complicated.
Yeah, well, I don't think they've done
Packages
much.
for that?
I don't think they've done much with the grounds. The assumption is the ground is flat under the antenna, not even like it's on the side of a hill or something. The original version of NEC, way back when, the Naval Ocean Systems Center would actually model like a battleship flying bridge, the whole 9 yards, all the metal and everything. And you could do it. It can be done, but not this version. Yep.
Because that would be interesting to model like an antenna in different places on the car.
Well,
Some articles talking about, ideal placements for antennas and things like that.
which are usually covered by just putting them and measuring it, right? Running around.
That's what I did. Found out where on my car the antenna gave the best performance.
How do you define performance? Because actually that was kind of my second question is you can get SWR, but that's not the whole game. What about radiation efficiency? The classic examples like an 80-meter mobile whip. Your SWR can be great, if you're at the right frequency, but your antenna efficiency is like, 1% maybe if you're lucky. Can you get?
Yeah, I wasn't trying with an 80-meter. I was doing with a 2-meter.
Well, I mean, if we were doing this, we would put the antenna on the car, go out in a field somewhere, and run around with a field strength meter. That's how it's traditionally done. For example, at RCA Moorestown, they had a massive antenna range there before they built the Cornfield Cruiser. They had quite a lot of antenna field work done out in the field there in Moorestown, New Jersey. So basically, that's how you do it. You actually measure the far field pattern. So you could do that. Maybe there's a Q Street article. Maybe somebody's actually done that in the past. That would be a good thing to do. I just got the current issue of QEX. If you're interested in antenna propagation, these people seems to be I think it's a husband and wife actually measure the effects of metal obstruction on radio wave propagation. So the QEX is the technical journal. I haven't got a chance to look at it yet, but obviously people are making measurements in the field. This one is actually, it shows a Yagi type antenna and a bunch of reflectors that it's bouncing off. Of course, they live on a lake, so I guess they had a nice flat measuring thing. They probably rode around in a boat to see what the far field would look like.
Can you get total radiation efficiency? Is that one of the outputs that you can get? Percentages radiated?
Well, you can get reflected power, which is certainly a good indication of at least how much power is getting to the antenna. You can get gain in the direction. So for example, like this log periodic, we can see the gain's about 3 dB in the maximum direction, right? So does that give you a rough, is that what you wanted to know?
Like the total percentage of the input power that gets radiated. So if I put 100 watts in, how much actually goes out to the far field?
Well, as you know, Jeremy, just because you have reflected power, the power goes back to the transmitter, gets re-reflected, gets sent back up to the coax, back and forth, back and forth, back and forth, right? So even SWR is not really the final dimension. In fact, in practical measurements, people measure it with a field strength meter, basically measuring relative field strength as you run around of a real antenna, making a pattern measurement. So if this was the antenna, they would put it in the field somewhere, and you would start running around, and you'd be able to get these particular points, including off the side lobes and things like that. Because you would see the field strength drop, essentially go around in a constant circle, but you would be able to make measurements of how strong the antenna is.
So this might be one of the things that really can't be modeled, because then you have to know a lot more about the losses in your feed line. Because back and forth, but a lot of that ends up just heating up.
Well, there is a thing here called wire loss, and you can put feed line. You can put copper feed, for example. You can give the resistivity and the relative permeability. So you're actually modeling the transmission line itself with losses. So you can do wire losses. That, I believe, that would also then modify the results. Right now we're dealing with wire loss of 0. So we're not assuming the transmission line has no losses. So whatever gets reflected gets sent back again. That's probably why it looks as good as it does. Let's try. Let's go back to. It's not going to do. Let's do this. Let's go back to the dipole antenna, I guess, which is a good place to start. So, open.
If you have lossy coax, your SWR gets better, but your radiated power gets worse.
Well, let's see that. Let's see what that looks like. Let's try the good old backyard dipole. Why is that upside down? Okay. Gotta make a look in half of these, and that would help. Come on. There you go. Backyard dipole, X, Y, and Z. Okay, there's the backyard dipole. 14 megahertz, whatever. And let's change wire loss, right? Let's make the wire loss copper. And I'll just go with the values they gave me. I don't know what the resistivity in ohms per meter, what that really means, but we'll just say okay. And again, you would do it with and without is what you really want to do. So let's do SWR, 13.75. As you can see, you could spend the rest of, this is probably better than Facebook, right? You could spend the rest of the night just doing these things. Not 13.7, I'm sorry, 13.5 again. And 14.75.
This is the antenna wire, right? Not the feed.
This is the transmission line. This is the antenna wire, yeah.
Okay.
Before we had perfect wire. So that's
are you modeling the feed line here? Are you telling it what type of coax you have, or
well, to get
your ladder?
You can do the characteristic, and I'll show you that in a second. This is the wire loss itself, and so that's what this looks like at 75 ohms. We'll try to maintain that as a picture. Change the wire loss. Let's see if it changes much. Okay, let's try to get this just for our own edification. Frequency 14.45 megahertz, 1.12. Okay. Change the wire loss to 0. Go. Okay. Hit SWR again. Run it. 14.45 before. 14.45, and the VISWAR is just a little better as a result. Okay. So let's see about coax transmission lines. You can specify the transmission lines, but you have to put wire size and how long they are and stuff like that. So again,
you can't just select like a RG8 or something like that.
The 237-page manual.
Mhm. Are there other questions for Dennis?
Well, you can change the characteristic impedance if you want to make it like 300 ohms or something, like with a balun, 4-to-1 balun. Let's see what that does. Nope, doesn't do too well. Okay, all right.
Now, the SWR you're getting, that's the feed point SWR or the SWR at the transmitter?
That would be at the antenna, essentially. Again, the assumption is the transmission line's not really playing a role here, unless you went into putting a transmission line in. That's this guy right here. You have to specify.
That's always a big part of it, because if you got long, lossy coax, your antenna's not going to do very well.
One of the columns here is loss dB per 100 foot. You have to specify how long of a feed line, and then the loss of the feed line, etc. Okay. But again, it gives you some capabilities of doing things without actually building it, which is kind of neat. I would imagine too, you could try different coaxes, see if you want to spend the money on something more expensive.
All right. Other questions?
So that's EasyNet Pro. And for what it's worth, let's see, screen sharing. Share, who's using Chrome? I'm using it, of course. Somehow I got into that mode. So EasyNet, sorry, here it is. Here's his website, free, version 7 now available. I think even if you are only going to use it sporadically, it's still nice to have. And here's the printable manual, all 237 pages. A couple other links to some other things. Okay, well, that's it for me.
All right. Let's thank Dennis for presentation. That was great.
Thanks, Dennis.
Thanks, Dennis.
All right. So before we go, Jim was able to join us. Would you like to give us an update on Field Day?
Certainly. And I'm sorry I was late. I had a work meeting on the West Coast, but Field Day, we're we're actually a month out. We're scheduled, Lou and I are going to pick up the material on Friday and take it up to the Field Day site from where it's stored. Hopefully Lou won't get sucked up in a tornado. I think he's out storm watching right now. So one question I do have, Jeremy, have we done anything with the scouts? Any signups or how's
I
that?
just reached out to the Scout executives for Chester County, so we're getting into the newsletter for them.
Okay.
So that should go pretty quickly.
Yeah, those spots usually fill up fast. Anyway, Saturday morning, I'm going to get there early, but if some of you can start getting there around 9, we can start the setup, get everything set up, and go from there. We don't have the beam to set up, the 6-meter beam. We just have dipoles, so it should go fairly quickly. Obviously, we'll have plenty of food, snacks, and things like that. So does anybody have any questions or anything I'm missing at this point?
I just wanted to add as a comment on, was it June 21st, the Tuesday before we're planning to have the meeting to talk about Field Day?
Yes,
That works with you?
that works perfectly, yes.
Okay, and that's the third Tuesday, because, the
Yeah,
way
and we
it
can-
works, it's better if we have the meeting before.
Right, and we can iron out all the details. What we will also want to do is, try to get as many people as we can. I know some of you are going to be attending other Field Day sites, but you're certainly welcome to attend more than one. We have 3 that I can think of that a lot of us are members of, but ours is probably a little more laid back than other ones, but we always have a great time. So come on, come all.
You said we won't have the 6-meter beam?
No, didn't we get rid of, we never didn't.
The tribander.
The tribander, I'm sorry. Yeah.
So we do have the 6 if we wanted to set that up.
Yeah, but well, we can talk about it and somebody's really for it. I mean, I don't know that we have to set it up, but we can certainly talk about it. It's all about,
Somebody brings a 2-meter beam and usually we can make some contacts on that. And that's a lot easier to set up.
absolutely, absolutely. If anybody has equipment that they want to bring, antennas, whatever, the only caveat is if you bring it, it's shareable. So make sure that you're okay with sharing. And I know all of us are very careful, with other people's equipment. So, and obviously we still have our equipment, so we'll get all that together, get it set up. So
Jeremy, I had the 2 and 440 Yagi last year with the ICOM 706, so I'll bring that.
oh
Yeah, that
was
would be
great.
good. Yeah, because
Yeah.
we could probably even put that on one of the big long masts. That would get it up a little higher.
I don't have a
Right.
6-meter antenna though.
Yeah.
Even though the ICOM will do 6, but I don't have a 6-meter antenna.
I mean,
Maybe between now and
you're
3
vertical.
No, you need a Yagi if you're going to do anything really serious.
Yeah. mean,
I'll-
a
I'll-
dipole for 6 meters wouldn't be too bad. Yeah, like some ham sticks.
I had this wild thought because I used to own a 6 and 2 meter Cushcraft, what they used to call a portable beam, where you just push the elements in. So I'm gonna keep looking, see if it's still around. Maybe I'll buy one. That's real easy to knock down. It was 6 and 2 meters because nobody cared about 440 back in the 60s.
Yeah, Jim, I have the rig blaster that I got at the last Ham Fest.
Right.
Want to do some digital modes? We can do that.
Wonderful. I mean,
Or I could just bring my KX3. We could do digital with that. Remember, that was kind of fun late at night running FT8, making contacts.
oh, absolutely. I
5
mean,
watts.
obviously, I encourage you, bring as much as we can. I'm gonna try to bring some solar panels and a battery and things like that. Some things just to show and tell. But the one thing, the 6 meter, the 718s don't do 6 meter. Do we have other radios that do?
The ICOM does 706.
Okay.
I'll bring my ICOM to 706.
Okay, good. Yeah, because I know your KX2, that doesn't do 6 meters, does it, Jeremy? Or
No, it doesn't.
right?
The KX3 does if someone has that. But that's low power. That's not fun.
Yeah, that's you can only get maybe pushing it 12, 15 watts out of it. So
I mean, for 6 meter antennas, the G5 RV should tune up on 6. And
No, but you really want to run a horizontal Yagi type antenna. That's the only way to
that would be better. But yeah, if you just wanted to make contacts, if the band was hopping,
okay.
a 40 meter dipole would tune up on 6 as the 7th harmonic.
Yeah, and basically
Crazy
put
stuff.
the signal right into the ground, probably. We can use EasyNet and model it.
Yeah, there you go.
Some options for that.
I'm hoping our strings are still up on the telephone poles, so we should be good. Other than that, we're
Hey,
ready.
Jim, would you like me to bring the rig blaster over to your place at some point? If you wanted to check it out with the radio?
With the 718?
Yeah.
Sure. I mean, yeah.
And maybe sometime next week I could drop it off.
Okay, well, give me a call and I'll see where I'm going to be here and there.
Okay. That way we'll have that as another option to do digital contacts.
Well, how about this, Jeremy? Are you going to be at the parade on Monday?
Yes. Oh, that would be perfect.
Just
All right.
we'll switch it then because I'm going to be at the parade. I couldn't make the French Creek, but I'll definitely be at the parade.
All right, perfect. Actually, the FT8 might be of interest to the scouts too. They might find that interesting, making contacts on the computer.
Absolutely.
Especially if they're good DX contacts.
Yeah.
I mean, yeah, with FT8, well, you're going to basically nothing. You could contact Eastern Europe and South America easily.
Right.
Or you can call them on the phone.
But you got to get Verizon for that.
Yeah. That's what a cell phone's for now. We have merit badge counselors certified and all that. We're all good.
Me and Brian.
Okay, and me too.
Right.
I'm all certified and good to go too.
And I don't know, and Ron might be around as well.
Okay, so we're well covered. So
yeah.
Okay. Looking forward to it. I mean, I'll obviously be spending the night. Hopefully I'll have company.
Sounds good.
The website's been updated with the scout information, Jeremy, so they should be able to,
Okay. All right. So anything else for good of the order? All right. If not, we'll adjourn the meeting and hopefully I'll see a lot of you at the Memorial Day parade
or at the Saturday breakfast.
Breakfast on June 11th, or else the meeting on the 21st.
Right.
Field day.
We got a lot going on.
A lot going on. This is the beginning of our busy season.
Yes.
All right. So 7-3 to all. See you next time.
Hey, Jeremy,
Take care,
thank you,
everybody.
Dennis.
Thanks, Dennis.